I'm going to kick things off. So thank you all for joining us today. I'm Suzanne Fletcher. I'm a general partner with Prime Movers Lab. And Prime Movers Lab, we are an early stage deep tech fund, investing across 6 broad industry verticals: energy, infrastructure, manufacturing, transportation, including space transportation, the future of computing, and longevity. And in setting some context about why we're launching this webinar series, there's so much interest in the underlying technologies and investment opportunities that we are seeing. We very much want to continue to build our Prime Movers Lab community and family opportunities around that. So this is a very emblematic of our style in terms of bringing together industry experts and showcasing some of the amazing entrepreneurs we've been fortunate to work with, one of whom is on this call, and as well as industry experts on this call. And it's an ability for us to kind of highlight the important work being done by prime movers or folks kind of positively impacting billions of lives. In welcoming this audience, a lot of folks on the line are our limited partners, our founders, our extended Prime Movers Lab family, and a kind of a special welcome to our Prime Movers Lab Fund 2 LPs. Housekeeping, we're going to keep this to an hour. Please put questions in the chat and we will weave those in. And with this, I'm going to turn it over to my partner Carly, who is our partner and principal engineer on the team. Carly, you're on mute.
Starting off with a bang here. So my name is Carly Anderson. I'm one of the technical partners here with Prime Movers Lab. I have my PhD is in chemical engineering. I've worked across the energy, materials, process engineering landscapes. The most relevant piece to this discussion is I designed carbon capture CO2 removal processes for a few years before joining Prime Movers Lab. I also authored our thought piece on carbon capture that you can find on the website. And I'm really excited to extend this discussion today with 3 great experts in this space. So Bill, would you like to introduce yourself?
Thank you. It's a pleasure to be here. I'm Bill Gross. I'm the founder of Idealab, a technology incubator here in Southern California, and also of a company called Carbon Capture Inc., which we'll talk about today. I grew up in Southern California during the 1973 energy crisis, and that's back when we were at 300 ppm. And then after having some success at Idealab and having the resources to do something about that, to try and maybe take us back from where we are now at 415 back to 300, so our children can get the world that I inherited when I grew up, I really wanted to start something that could make an impact there. And I'm trying to use my mechanical engineering expertise, the resources of Idealab, and also the great partnership with Prime Movers to really make a company that can take carbon out cost effectively. I'm super excited about it. Carly has been amazingly helpful because Carly's written these thought pieces on it. Even during the diligence of investing in our company, she and the whole team at Prime Movers was helpful in making us a better company. And to this day, even more so. So I'm really grateful to be here. Thank you very much.
Thank you, Bill. It's been amazing to work with you. Matt, let's hear from you next.
Great. Well, thanks for having me. My name's Matt Lucas. I'm Managing Director for Business Development at New Energy Risk. New Energy Risk is an insurance company whose goal is to facilitate first-of-a-kind and first-view-of-a-kind project financings for clean tech and low-carbon technologies. We're part of AXA, which is a $1 trillion French multinational and the world's largest property insurer. I'm based here in the San Francisco Bay Area. Like Carly, I have an engineering PhD. I worked for a series of university spinouts in both technical and business development operations, had a stint with Siemens in their corporate venture capital group, and then most recently raised $10 million for a startup accelerator focused on carbon capture and carbon utilization. So bounced around academia, policy, entrepreneurship, and capital. So I think my contribution here will be to talk about how we scale these things from non-recourse financing point of view.
Great, thanks a lot, Matt. The beards during quarantine have been getting so much better. I really enjoy this. Volker, please finish us up.
Carly, Suzanne, thank you so much for including me today. And actually following what Matt just said about bouncing around, I started my academic career as a chemist, physical chemist, before accepting an appointment as a mechanical engineering professor at the University of Michigan. I'm still at the University of Michigan, still in mechanical engineering. But instead of working on combustion engines for the last few years, I've looked at what technologies can we help grow and promote that can take CO2 and turn it into a profitable business that helps the environment. So the following Bill's comment. So I was blessed with making the acquaintance of a number of exciting people, including Bernard David, who had founded the Global CO2 Initiative from four and a half years ago with a vision of creating a business opportunity. And we're excited at the Global CO2 Initiative now in Michigan to help make that dream and necessity come true. So glad to be here today.
Thanks, Volker. And so with that, we're going to start our inaugural web series covering carbon capture, and we'll be doing 8 of these. So same time, same place for the next 8 weeks. We'll be covering batteries next week. And our audience will vary in terms of technical levels on this, but we really strive to make topics accessible for all. And I know that people will not be shy in terms of asking any questions they have in chat or Q&A. So please just chime in and we'll make sure to get your questions answered.
Suzanne, can I say one thing?
Absolutely.
Listening to what Volker and Matt just said, Volker, you said that you were working, previously working in combustion, and now working on taking CO2 out of the atmosphere. And Matt, I know you're looking at so many things to try and make useful products out of the CO2 we take out. And if we can make fuel, like fuel from the stuff we take out, that's actually reversing combustion. Like together, maybe that's what we can do. Combustion is something that we used to do. And now maybe we can do reversing combustion where we take the stuff back out and go backwards. Previously, that was not a reversible cycle, but if we can make that reversible, that'd be pretty incredible.
That's it. Let's talk more about this during this hour.
Awesome. Well, so Volker, how about you kick us off? We like to start with the basics, really high level. What is carbon capture? And maybe what drew you to the space? I know you've already touched on that in your intro a bit.
Well, I think that really kicks us off with a really important statement, and that is we must be more careful with the words that we choose. Because carbon capture is in our community understood as carbon dioxide capture. Right? So we imply that we capture a gas, whereas carbon, could be a diamond. So I think that's really important to understand. It's capturing CO2. And that can actually happen either from air, where we come across the same kind of misnomer, direct air capture. We're not capturing air, we're capturing the CO2 out of air. But that just as a side for people to keep in mind. So taking that CO2 selectively out of a mixture of gas is what carbon capture is. And that can be from air or actually flue gas or industrial processes. So that we then have a tank of pure CO2 to work with.
Awesome. Actually, maybe we'll move from there to Matt, what do we do with the CO2 next? Or what types of things are out there? I know there's a wide range of projects and applications from the oil industry and food and other areas, but maybe you could comment on that.
Yeah, so once you have your CO2, and Volker, thank you for teeing up the fact that all carbon is not CO2. There's 3 things you can do with it, and only one of them is a real and viable business. But let's just review the world of opportunities. The first is what's known as enhanced oil recovery. So you take the CO2, you inject it into an oil field, and it helps you, and the oil company pays you for the use of that CO2. You can also generate a tax credit known as 45Q from doing so. And you generate more oil. The damning reason that this doesn't work is that you've tied your fixed carbon capture project to a volatile global commodity cycle. And we saw this play out at a Houston area power plant known as Petronova, where the cost of doing the carbon capture on the power plant was paid for by the oil price. The oil price crashed, and so they shut down the carbon capture on the power plant, so now the power plant is emitting more CO2. This just kind of creates a not terribly helpful process. The second thing you could do is turn the CO2 into a valuable product, and here you run into a impact versus profitability metric. So if you want gigatons and gigadollars, there's very few things that you can actually make. You run into something around concrete and rocks, which are very low value. And then you run into something like fuels. And in fact, the thing that makes the fuels even plausible is because of the incentives you're using. And you can generally just get to those incentives far more directly by doing the third thing, which is putting the CO2 directly underground in what's known as a geologic or saline formation. It's the same process as doing EOR, except there's no oil at the bottom of the hole. So that CO2 goes down and stays down. So in fact, I think it's highly unlikely, I'll never say never, but it is highly unlikely that we would ever support a project that did CO2 to fuels, because it's an inferior business model to going directly to saline storage, because the same sorts of incentives and policy supports that enable CO2 to fuels are also available for CO2 to direct storage.
Interesting comment, Matt. I think I know quite a few oil engineers who would, or people in the Shell, Chevron space who might disagree with you on that quite vehemently. Bill, do you have anything to add on the CO2 uses?
Yeah, well, I agree with Volker that it's very hard to do the direct air capture to separate the low density of CO2 out of the other gases in the atmosphere. In fact, just to give you some numbers around that, you have to filter 1.35 million cubic meters of air to get 1 ton of CO2. So it's basically like a Colosseum's worth of air. Like imagine taking the entire Roman Colosseum, blowing all that air through some kind of thing that can attract just the CO2 molecules and take those out. So it's hard, but it's a great problem. It's a great mechanical engineering and engineering challenge to do that cost effectively. Then once you have that CO2, like Matt said, yes, there's many things you can do with it. Incentives to get rid of it, to permanently take that out of the atmosphere, like bury it deep, deep in underground so it stays out for 3,000 years, those incentives are going up. And I think that's going to be one good way to finance that happening. I do agree with you, Carly, that I think, well, my goal is to make it so cheap that we actually can make fuel cheaper than fuel. And we can make renewable fuel or a cycle of fuel, because basically we release the CO2 when we burn fuel, then we capture it and we turn it back into fuel. That's going to be very hard. It's going to be very, very hard to beat the cheap price of just taking fuel out of the ground. But someday I hope to do that, because I do agree with Matt that that's the only $1 trillion opportunity. I mean, if you look at all the businesses on Earth that are big enough, the one thing is energy. Energy is like 10% of the entire global GDP. So if you could replace that fuel with a renewable fuel, that's scalable. Like that is a scalable way to solve the problem. But it's a very hard problem, because to do that cheap enough is very, very challenging. But the physics doesn't say it's impossible. So it's just going to take a lot of clever engineering to make that happen. And that's why I'm so excited about the opportunity.
Right, and I might like to add that from a technology point of view, that's a solvable problem. It's especially a solvable problem that is now within reach, because we have carbon-free electricity and other forms of energy to make that happen. Because from a chemistry point of view, it's easy. All it takes is an enormous amount of energy. Yeah. So let's do that away. But in terms of the infrastructure we have, at least for a long transitionary period, it keeps our economy and our daily lives going, right? Because even if we want to all buy electric vehicles and electrify our water heaters, etc., it cannot be done fast enough, right? So having that energy carrier made out of CO2 makes some sense, because let's not forget, while I agree with Matt on the economics of it in the context of current policies, we also need to look at not adding more carbon to the above ground balance, right? And that recycling here makes sense. But I also do want to point out that this is sort of replacing the source of carbon for a commodity, a product that we already make out of carbon or use carbon based. But CO2 utilization opens up opportunities to create entirely new materials. If we look at how we can make mineralized CO2 rocks, essentially as aggregates for road fillers, buildings, we can make concrete. Typically, concrete is not made with CO2, but here we can actually use that as a permanent lock-in for the CO2. So many exciting opportunities that also create economic wealth at a sizable level.
And a lot of themes of the circular economy, right? And things being reused, which we're excited about. I would love to kind kind of go to the why now, right? A lot of life is timing, and timing is really important. And so I'd love to get your guys' take on kind of climate tech, carbon capture. What critical things have changed in order to make this more feasible now than it was before, and kind of conversely, what challenges still exist?
I start by saying, I think a big part of that is just heightened awareness of how acute the problem is. Right? I mean, there are more and more studies out now that show even if we scale up as fast as possible today, we are really late. We're already late in making sure that, I mean, look around, look outside. I mean, look behind Carly in the window that we see. I mean, it's not normal at that time of the day and year that it's dark out there. So I think it's really that recognition that we cannot hope to solve the climate issue with just trying to be less wasteful and reducing the CO2 addition. We need to actively remove it. And we need to do this very, very fast. I think Klaus Lackner always does a great description of the magnitude of that problem. Right? We cannot possibly build the machines fast enough to get this done in a year. So starting now is important.
And Volker, beyond that, why should we invest in this now? Because we are all, I think, aligned on wanting this wonderful, better world for our children, ourselves, everybody. But how are we going to get there, and how do we as Prime Movers Lab and the investor community support that transition, and what makes now the right time to finally get involved?
If I continue, I mean, I think obviously what I just said is an important element, but also I think looking beyond what have we achieved if we have saved the planet? Do we then throw away millions of installations and throw away a lot of investment, even though it might have paid for itself and more? But I think that's not the case. I mean, if we stay with the use cases that we discussed, fuels, for example, or building materials, we might be able to use those for a long, long time, forever, right? So it's not an investment that is, let's fix the problem and then it's lost. It's really an investment for the long term, in my opinion.
Suzanne, I also think that, like when you're saying why now, what timing thing is making it happen? Absolutely, what Volker's saying is the problem has gotten so severe, you don't have to convince anybody anymore. Or maybe there's some people you still have to convince, but that's one. The other is investment. 10 years ago, you couldn't get investments for this. It was very, very hard. 5 years ago, it was very, very hard. Now, people like you guys are forward thinkers, you guys are thought leaders, are making investments in this. But that's one factor. Like, we couldn't do this if it weren't for people like you leading the investment. But the other thing about why now, Volker said as well, you have to take the CO2 out using renewable energy. You can't use fossil fuels to do it. Like Volker said, this is an energy problem. It takes energy to take the CO2 out, to go backwards. Like the easy thing is to release it. You burn stuff and you release it. Now to pull it back, you have to use energy. Well, if that energy is also fossil fuel energy, that's a defeating, that you can't ever get there. Renewable energy has gone down in price so much over the last decade that now you can have renewable electricity, lowest price ever, just went in, 1.35 cents a kilowatt hour, big gigawatt installation in the Middle East. We're working on making heat, thermal heat, for less than 1 cent a kilowatt hour at Heliogen. So the idea that we're on the cusp of having cheap enough renewable energy to do it is the new thing that makes it possible. Maybe a third factor is, and it's a little bit to do with the awareness, but the world is starting to get closer to putting a price on carbon that properly charges for the externalities of what it's doing to the planet. Now, the price is not right yet. It's $15 to $20 a ton, or $35 a ton, Microsoft is setting. It's too low, but it's non-zero. And a decade ago, it was close to zero. So if that price creeps up a little bit, and we use our technology and cleverness to lower the cost, we can get that crossover point. I think the reason the time is now is that crossover point is within sight this decade. Whereas a decade ago, even 5 years ago, it wasn't in sight. It was like, it's not going to happen. So that change that we're on the cusp is technological and social. It's both. And if more companies and more countries come and set that price that properly charges for the externality, then I think it really is going to become possible this decade.
And Bill, I love that you drew out some of the carbon prices that we've seen coming out of Microsoft, and also coming out of some of those programs like the airline ones where you can offset your flights, or Nori or Pakama, or some of the other startups that are doing blockchain tracking of these projects for companies that want to venture certain levels. Matt, I want to give you the opportunity to respond to this as well.
Yeah, I mean, fair enough, Volker and Bill. I think far and away the question is like, this is, at least at the project finance level, all about hard numbers.
Sure.
And Bill, even if I gave you zero cost renewable electricity, you still have to service your CapEx and your OpEx.
Yep.
And so you still need something beyond cheap renewables. And that something is public policy, whether it's in the US tax credit in the form of 45Q, and we can talk about that, or in certain circumstances, California has a low carbon fuel standard, which permits this sort of saline storage. Let me be clear, you only do carbon capture if you believe that climate change is real. And because it's an externality, you have to believe in the staying power of public policy incentives. This is unlikely to be something that gets solved through purely market-based incentives by itself. And so if you're going to be an investor in this space, you have to have a comfort with the staying power and the role of government. I mean, that's not unusual, right? If you were a pharmaceutical investor, you understand it's one of the most heavily regulated areas. Energy is even more heavily regulated than pharma. So there is no such thing as a pure play. And I think it's just important to note that you do have to have this comfort and willingness to accept public policy as part of your business model here.
And what do you think the role maybe is of, beyond public policy as well, some of the movement we've seen from big corporates? So do you think that, is there, I'm just throwing, like, as a thought experiment, are the Microsofts or the Googles or the Amazons, or will Bill Gates or Jeff Bezos, or, just high net worth individual, where else do you see those other sources of drivers playing a role?
Yeah, so, I mean, well, okay, so Bill, I'll answer and then you can disagree with me. So I look at scale of dollars. So if you're going to deploy, let's say, $100 million direct air capture facility, and you're going to put the CO2 in the ground, you need, that facility is going to need to generate, what, $50 million a year in gross revenue. So it looks like if you took all the corporate commitments today and quintupled them, you wouldn't have enough revenue to drive even just one very moderate sized facility. So you're right, there's a lot of corporations in the world, they could all grow. The reason I think that's part of the solution, but I look for something that is durable over 5, 10, 15 years, the asset life of that horizon is the public policy and those sorts of market incentives.
Yeah. No, I agree. We need to do this on a global level. We have 7 billion people. One company's commitment can't make up for the output of everyone else. But Microsoft starting, I still think, was impressive. Like I heard the guy from Microsoft talk yesterday about their commitment, and he said it in a really great way. They've committed $1 billion so far, so at least that's some number of years of a plant if you can take the CO2 out cheaply enough. But they committed $1 billion so far, and they have more to commit because they not only want to be carbon negative as a company by 2030, they want to be carbon negative of all of their historical emissions to date since the company was formed in 1975. And their view is very enlightened. Their view is the company that we are today is because of those emissions, meaning we wouldn't be where we are. We would have never made the impact we made as a company if it weren't for those. And we feel guilty about that, and we want to negate all of them. So it's one company, but they are going to guilt other companies into following them. Someone like Salesforce will follow them, and someone else will follow them. But we need governments to do it. Like, I totally agree with you, Matt. But companies can get the momentum going. Even look at how the mood and the sentiment has changed, just in the last 4 or 5 months over Black Lives Matter. We need to make those kinds of changes, I believe, on carbon. We need the whole world to feel that this is important enough because then governments will respond to it. But I do agree with you. The scale of the problem is so large, it can't just be solved by companies, but companies can make a big difference in how they change public sentiment.
I guess I'll just share, at New Energy Risk, we've got over $1 billion worth of carbon capture projects.
Wow.
And none of them rely on Microsoft.
Wow,
They're
yeah.
all 45Q and LCFS.
Yeah, right.
So
Good point.
like there's a difference here about like, are you visionary and you're hoping in this future that might evolve versus the between here and 2025 world.
Right.
And you're right. I mean, these different sources of capital, different time horizons, but
Right.
I mean, you got to make money this decade, right?
It's all needed, all necessary. But I think an additional way to look at that is, of course, coupled with the problem that we don't sense the immediate negative impact of CO2 as humans, right? It doesn't smell, it doesn't stink,
Right.
doesn't look funny.
Look at the window.
So it's a bit of a challenge to sort of make people recognize what disastrous impact CO2 levels have in the atmosphere. But fundamentally, I think what needs to happen to sort of overall push a broader global policy landscape, or including procurement requirements that guarantee that this business grows and stays, really has to do with waste management. Right? Look, centuries ago, nobody paid for sewage, nobody paid for garbage pickup, etc. It all has become a necessity because, I mean, people die because of cholera and other outbreaks, right? So we have, in a sense, a similar situation. And there will have to be a steady state support, because otherwise, couldn't agree more with you, Matt and Bill, that without that community support, let me call it that, it will not work financially.
Yeah. Well, one thing in support of what you're saying, Matt, on the government incentive is, I'm thinking what just happened with the PV industry. So PV panels were, way too expensive 15 years ago. A bunch of governments stepped in and gave incentives. A lot of people screamed at them as being too generous, and why are we doing that? And Germany was propping up the PV industry. And at one point, the total market cap of all the solar panel companies in the world was exactly equal to the German subsidies of like 100 billion that had been provided. But, and that seemed like a negative, but it turned out to be a great positive, in that the price kept coming down, the learning curve kept going along. The learning curve was 19%. Every doubling of volume led to 19% lower prices. And now here we are with PV almost too cheap to meter, and people being profitable doing it, and the subsidies are needed. It took us 15 years, but it was a lot of government support. Now, this problem is bigger than PV. There's no question. This is a bigger amount of money needed to take all the CO2 out. But it's a similar type of government. Many governments around the world all contributed. U.S. government had an investment tax credit. Spain had a heavy subsidy. Germany had the biggest one. Italy, many countries all participated. And I hope we can do something like that again this decade on this one. And again, the awareness is there, so maybe it will happen.
And Bill, thank you for making that. The point about the why now, that very much makes the point about timing is very important about when you're going into that, and making money this decade. I can assure everyone on this webinar is something very top of mind for what we're looking at in assessing these opportunities.
Well, and I wanted to touch on two important things that I think were just said. Bill, one on the cost of solar coming down over time, and how the cost of carbon, like CO2 capture, direct air capture, might come down over time. I also do want to highlight Volker's comment on the waste perspective on all of this. As you start viewing more things as waste and creating, if there are mechanisms where that actually comes into play. I hadn't thought about how I now have my sewer bill, but maybe I didn't back in the 1700s. I thought that was really cool. But on falling costs, maybe where are we today in the cost of CO2 capture, and where do you think that will end up in the next 5 to 10 years? I'll start with Bill. I know you've thought about that. We've talked about this before, so I'm cheating a little bit with that.
I think most costs right now are in the $200 to $600 a ton range, with projections to get down to $100 a ton. We feel that at our company we're at about 150, and we want to get down to 50. It's very, very hard to break 100 right now, but I think long term we've got to get down well below, everybody, has to get down well below 50. Again, it's not physics impossible. It's engineering challenge. It's like Matt was saying, you got to get the CapEx down, you got to get the reliability up, you got to get the duration high, and you have to get the energy cost low. But you do all those things and you can drive the cost way, way down. But I think right now, everyone in the world feels like they're targeting break 100 reliably, and you can have a really good business because the summary of the government subsidies is above 100, and therefore you can make a profit if you can get below 100.
Well, okay, that takes let's break that apart a little bit. So one is there is locational pricing for CO2. So just to be clear with the audience, what Bill was referring to was direct air capture prices for central plant. Now, the same way we have central plant, those are called solar farms. You can also do distributed solar, put it on your roof. It has a higher price because you didn't have economies of scale, but the value of solar at your home might have a larger value, so it still works out. So for instance, you might put your direct air capture machine next to the Coca-Cola factory. Other companies have already done this. There's a question about whether the additional costs of siting the DAC there, the direct air capture there, and the higher operating costs there net out with the higher locational marginal cost of value of the CO2 to Coca-Cola. Either way, it's not a gigaton or a gigadollar business, so it's unclear if that's venture scale. There's a whole separate issue that's not direct air capture, right? That's point source. So that's what Petronova is. That's what Carly worked on in her previous job. And those have much lower price points, right? So let's be clear that you already today can hit under $100 a ton from point source capture. And that's totally valid and a great emissions mitigation. It just isn't carbon removal because the air is not coming from the atmosphere.
Yeah. One more thing for other people on point source versus pulling it out of the air. When you have a point source, like the CO2 coming out of the smokestack of a power plant that's burning fossil fuels right there, the density of the CO2 gas in the stream is very high. When you have direct air capture, like out in the desert or out in a field, the density is very, very low, only 415 parts per million, so very, very low. It's all over the earth, but it's very, very low. Now, it's very, very high compared to what we should have, but it's very, very low in that it's very diffuse. It fundamentally takes about 2.5 times more energy to take the CO2 out of the air when it's diffuse like that than when it's dense. So you have a 2.5 times energy advantage to taking it out at the point source location where it's actually being emitted. But it could be that that 2.5 times advantage isn't worth the other benefits of being right next door. But physics-wise, chemistry-wise, you have that advantage. And for all the things that can do point source, I sort of think they should. One of the great things about direct air capture is it's for all the things where it's not easy to do point source, like the tailpipe of your car, which is not easy to do because it's a mobile device that's moving around, and but for a factory where there's a huge point source emission, that is a great place to go. And again, if the incentives are proper, companies should make that investment because the ROI can be very strong.
Yeah.
In a way that brings me to another aspect of all that. That's sort of the co-location of where CO2 is being captured, whether it's from air or from point sources, and what happens with it, right?
Yeah.
If you have an injection well right next to it, that of course saves a lot of complexity and cost. If you have a concrete producing facility next to it, same thing. But what you just said, Bill, about direct air capture being more flexible, or the decentralized setup that Matt described, I think that opens up a really fascinating opportunity for direct air capture. And that is to be located where currently there is no economic prosperity, right? In areas that have land that are not arable, where we can probably set up large square footage of solar cells to create the electricity needed and create opportunities for jobs in underserved regions. So I think as a global society, we should look into those as a huge opportunity for development.
Yeah, I totally agree with that. We are focused on direct air capture in particular, like a little bit like, if you have a hammer, everything looks like a nail. We have a technology to make very, very low cost heat in the desert. So we want to go do direct air capture in the desert where, like you said, there's not much other good use for the land. the sunshine is plentiful, and maybe we can make CO2 and water in the desert, and all of a sudden have other economic benefits. And that's what I'm hoping to do. So that's our particular angle. And I agree. It's completely different than doing point source capture, but it has some other benefits.
And Bill, with carbon capture, I think it really hits home when you mentally describe it as turning desert into forest.
Yeah,
yeah. Functionally, what's happening.
Yeah, a forest that you plant of trees will also take CO2 out of the air, but it takes 150 acres of forest and water to get that ton of CO2 per day out. In only 1 acre, you could do the same thing with a solar system. So you could be like 100 times better than a forest. And you can go to land that you couldn't turn into forest. So in that sense, yeah, we love to use that slogan internally at the company, turning desert into forest, because we'll go take a piece of land that you couldn't use and effectively make it act like a powerful forest, but in 150 times more efficient use of land. And also importantly, there probably isn't enough unarable, currently arable land to plant enough trees to take out all the CO2, but there is enough desert to take out all the CO2. So I like the idea of using desert in a way, exactly as Volker said. You can't use, it's not useful for other stuff, but it's useful for this.
Yeah. And so I want to take this opportunity with where we are to just remind our audience they can ask questions on chat or on Q&A, and Carly and I will make sure that they get answered. No question is out of bounds here. Please feel free to ask technology, investment, opportunity-based questions from our guests. So we'll let you chime in, and we'll ask one more question ourselves while we wait for some of the audience questions. I would love to talk about kind of clean energy companies and their access to capital, and what has been your experience. Maybe I'll start with Bill on here, but in terms of what you need to show as a company in this space in order to kind of gain access to capital. I'll be interested to involve Volker and then Matt too on the different sources of financing and how that varies by what you have to show.
Well, it's been very hard up until recently. There has not been very much investment in clean tech after the last surge 10 or 12 years ago. After the last financial crisis, a lot of money dried up for renewable energy. A lot of good investments were made by the government and a few bad ones, and those bad ones tarred everything else, so it dried up. But now it's changed, partly because of the awareness. But I would say the biggest reason is what Matt said, which is you got to show a business. You got to show a return. Like, investors are looking for return. So if you can show financial viability, like a path to economics that makes sense, then you can attract investment. And that was required for us to show you. And it's great that you demanded that, but we're now able to show that. And we weren't able to 5 years ago, partly because the technology wasn't there, but partly because, as Matt said, the government support wasn't there. So the government support combined with technological advances make it that you can show viable path to economic return, because you have LPs. Your LPs are doing this partly because they want to make the world a better place, and partly because there's financial returns that need to be made as well. And I think that clean tech companies have to show that now.
Yeah, I would second that, and maybe add a university perspective to this. I mean, for us, of course, we start with the idea, right? And what kind of technology would be useful? How can we make it? And the curve to get to a real investment to grow is really, really super steep for us. If there is not this government support to develop to a technology readiness level where investors actually get interested. We see a lot of excitement for some of the university work we do at Michigan and support elsewhere. But once the investment community looks into the level of readiness, it's a little too early, right? Come back later. Well, okay, so where do I turn to bridge that gap, right? The often cited valley of death. So from our point as the source of inventions, that is one of our key issues. Even though we have a flourishing infrastructure and support network on campus and with external communities, it still is that sort of risk in investing into something bad, as Bill cited the examples.
Thank you guys. And we've got some audience questions coming in. The first one,
We let Matt comment really fast on that. I saw he was about to unmute himself. On
yes.
Sorry, Suzanne. I guess I just wanted to take a later stage perspective on this, because what happened in Clean Tech 1.0 in like 08, 09 is that VCs built physical assets, solar panel factories and biofuel facility with venture dollars. And that's hugely dilutive and really bad for everybody. So the way you get around that is with non-recourse, non-dilutive project financing. And the key thing when you think about a project financing, most venture capitalists and most entrepreneurs in Silicon Valley don't understand project financing as a general rule. And that's been the challenge here, is how do we evangelize that? There's really four things, right? You need creditworthy supply, you need a buyer, you need operations and maintenance, and you need proven technology. So somebody like New Energy Risk can handle the last two by insuring you, but you still need that long-term buyer, not a year-to-year or a merchant market, but a long-term creditworthy buyer. And then you need a feedstock supplier. And in the case of carbon capture, you're going to hook up to somebody who's emitting CO2. The question is like, well, is that power plant or that industrial facility going to be around for the next 20 years? It's a great reason to do DAC, direct air capture, because there's no feedstock necessarily. But understanding how you bring all of that together is how you're going to make venture capital be a fit to clean tech. And I think that's something that's been questioned, is like, oh, can VCs do clean tech? And it's, well, yes, if they learn how to do project finance at the appropriate stage.
And Matt, I want to get to our questions in a second, but really quickly, is the LCFS, does that count to you as an off-taker or a buyer? LCFS being the low carbon fuel standard in California, which
depends who's buying the credits. So, right, LCFS isn't like a government market. There's obligated parties like oil companies who have to procure them. So you go to Chevron or Tesoro, and you would need not an indexed offtake, but a fixed or a floored price offtake. And I'm happy to handle this offline at greater detail. So yeah, you need the right person to buy, the same way that, if it's like Joe's gas station down the street, they could buy your biofuels, but they're not creditworthy. You need a Chevron or Exxon to buy them.
Great, thanks.
Yeah, and thank you, Matt. And I know project finance is something we've been big proponents of within Prime Movers Lab and exploring those alternatives. So really appreciate you bringing that up. First question from our audience is directed toward Bill and is about carbon capture as a company, asking about kind of what's the time frame for it becoming cash flow positive, and how much non-dilutive funding is there that could potentially also go alongside venture funding for this?
Well, I'm shooting really hard to be cash flow positive in 3 to 5 years, and hopefully doing it on only, say, $20 million of dilutive capital, but then doing exactly what Matt said, getting non-dilutive capital that's project finance to scale things bigger. Matt outlined the problem precisely, which is in this industry, in all of these clean tech companies, you make a product that is going to run for a long time and earn its earnings over a long time, unlike an iPhone that you make for $600 and sell for $900, and all the profit is made on the day you sell it, maybe except small or extra earnings on the App Store, but the majority is made on the day you sell it. Here, the majority is made over the 20-year period. So you have to prove things. You have to prove viability. You have to prove longevity. And then you have to get some of the data from that before you can get project finance. But project finance is instrumental to making this succeed on the scale that we want. But yes, I'm hoping we can do it in very short time frame, at least at a smaller scale, show cash flow positivity, and then use that and the track record of operation to raise bigger funding to scale it larger.
Thank you. And kind of building on that response, Matt, we have a kind of tactical question about project finance. We probably could do a whole webinar on that as well. But just questions about kind of how can VCs help get the right project finance in place, the buy-in required from governments and corporates, any kind of other specific tips or guidance you can offer the audience here.
So we network extensively with VCs, typically growth stage VCs, because referring your portfolio companies to us at New Energy Risk, newenergyrisk.com, is what we would ask of you. Now, if I were to say, is there a checklist? It really is country and sector specific. The norms in, say, liquid transportation fuels are different than in others. But in general, I'd lay out those 4 questions. Is your technology bankable? Do you have somebody who knows how to operate it and is willing to put their balance sheet behind it? Do you have a long-term, and long-term means debt tenor matched buyer who's investment grade? And if there's a supply, is your supplier likewise investment grade? Actually, getting all four of those things lined up is really hard. So the sooner you can start, the better. The people who provide those contracts and counterparties are very conservative and show me the numbers. So it's generally about getting some sort of a demo in the field. If you speak the vernacular of technology readiness levels, this typically means TRL 5 to 6 for 18 months. We're typically looking for at least 6 months of field operations to underwrite ourselves.
Yeah. Matt, I think you just outlined why this is so challenging. Think about all the challenges that a technology company has to develop and perfect their technology and overcome those obstacles. And then to add those four things that you just described, those are heavy hurdles that a climate company has to climb to win that later stage project finance. But it's crucial. That is the name of the game if you really want to make something that scales.
So there's a question that came in. Are there arid countries now who are willing to fund the CO2 and CO2 to water mega factory? I think that's something that you've talked about a little bit before, Bill. Due to their public policy and water needs, is there, and maybe we can broaden that a little bit to beyond just arid countries, are there certain localities where this is like poised to take off?
Yeah, I believe there are, but I haven't closed any of them yet because we're still a little bit too early to be approaching them. But I believe that most of the Middle East countries need water and will be willing to use that as part of a way to fund this. But I know we even need this in the Southwest United States. So I think it will not be a problem, but I haven't approached anybody yet, so I can't confirm.
Cool. And just to add, adding a little bit more context around what is this association between water and CO2? Depending on the humidity in the air, you're talking 10 times or more water in the air than CO2. And many of the materials that grab CO2 also grab water along the way. So often it's, you spend a lot of the work in pulling out CO2, also pulling out water from the air. Volker, didn't mean to cut you off there.
No, and you know, that actually might not be a bad synergy, because for a lot of the conversion of CO2, you need hydrogen, right? So that could be readily made out of that water that otherwise in a desert is not available to begin with. So I think there are multiple benefits from that CO2 and water extraction from air.
Yeah, I was shocked to learn that I sort of think as, you know, Florida and New York as being 100% humidity and deserts as being 0% humidity. But in fact, you know, Florida and New York are 70% and deserts are 30%. Like even in a very dry spot, there's still a lot of water in the air. By comparison, it's quite dry. But like you said, Carly, the water can be 10 or 20 times as much as the CO2 because the CO2 is parts per million and the water is 20% humidity. So it's way, way more. The idea of if you can cost effectively, again, take the water out of the air, it all comes down to energy cost. It takes energy to do that. But if the energy is the same cheap energy you're using for the CO2 removal, maybe you could use it twice. You can maybe make a big impact. And I'm hoping we can get a lot of interest from arid locations.
And there's a lot of very interesting tangential work on this topic too, being done around nitrogen coming out of the air and fertilizer implications and getting rid of Haber-Bosch, and just very interesting things that are getting done right now that we're tracking all these technologies at Prime Movers Lab and are excited to kind of see more things come to market here. Carly, I see we have one in Q&A that could be good for Volker to talk about. You want to ask that?
Yeah, and this is a bit of a large ball of yarn to unravel, but could you broadly outline the various types of carbon capture technology besides direct air capture? So this includes algae for carbon sequestration or others, and also comment, and others can jump in here, on the relative effectiveness and scalability of each. So non-deck technologies and how effective or scalable are they?
Yeah, I mean, that's certainly a very broad question. I mean, Bill already started pointing out the point source capture technology. And I think this is probably a good point to get into discussion of how pure does the CO2 have to be for what we need to do, right? If you pump it into your soft drink, you better want to make sure that there is no no heavy metals or whatever from your smokestack left in there. But to grow algae to make fuel or foods, you can probably, and there are efforts underway, you can just directly pipe in marginally pre-processed flue gas from an exhaust gas. Right? So it doesn't matter that there is water and other things in there. So it certainly depends very much on the technology for the use.
Well, and Volker, I want to tie this also to something that Matt said. I've heard of ethanol fermentation facilities. So these are the large corn ethanol stuff that goes into your gasoline. That's mostly CO2, and that's a great target for shoving underground. I think, Matt, you mentioned there are 45Q projects in that space that are at least queued up.
Indeed.
Indeed.
Same for methane reforming, right? To make hydrogen. So there you have hydrogen, you have CO2, and add nitrogen, you can make urea and other fertilizers. So there are certainly a lot of opportunities, but fundamentally it still is the same process, right? You need to, in most cases, at least capture it and somehow post-process it.
One thing that Matt said earlier that I was thinking of when you just said that, Volker, is how the really big scalable things are the fuels, but some of these other smaller things still might allow us to drive the cost curve down. Like they might not be the methods that we end up with solving the whole problem, but they could be good use cases to have some revenue, improve the processes, and get them down. And maybe some of the things like the algae or water or even soft drinks. You know, soft drinks is never going to be a big enough business to take out all the CO2 in the atmosphere, but it could be a way for a company to get a process down, get something bankable, get something proven, have an off-taker who's reliable. You know, Coca-Cola is going to pay for 20 years for, you know, things like that. So it could be that we have to crawl before we run and find some applications that bring in revenues and help us drive down the cost, even if they're not the eventual things that'll be fully at scale. Sorry, Matt, I think I cut you off.
So just Volker, the ethanol and the Haber-Bosch are actually great examples of where project finance has a lot of trouble with these. So in COVID, over half of America's ethanol plants curtailed or totally shut down due to lack of fuel demand, which means that if you were doing carbon capture on them, you would have run out of feedstock. So actually ethanol plants have a lot of ethanol plants with carbon capture, even though they are pre-purified, they're a very easy carbon capture source, are almost impossible to project finance. Fertilizer, especially ammonia, is generally not off-taken. It's very difficult to find somebody who will give you a 5 or 10 year off-take on fertilizer. So that's an example of a commodity that you can't get an off-take for. So that would make it very difficult for any of these air to fertilizer type companies to actually do project financing unless they're willing to find a new off-taker. So that's just sort of a weird niche. Bill, I just want to bring up, in the project finance world, the cost versus price versus value mechanism comes up. And I know you get this already, but I just want to clarify for the group.
Yeah.
Like Coca-Cola might say, we'll pay $600 a ton. That's their price. The cost to deliver that was probably more like 50 bucks a ton. And so it's a huge delta, and you'd say, oh, that's great, but then who's the incumbent? Praxair, Air Liquide, these are all billion-dollar companies. They'll just shove you down. Right. So when we project finance, we're really looking for, I need to make sure I get this right, cost advantage, not price advantage. Right. You know, the entrepreneur thing is always to look for the highest value, but in project finance, when you're doing these commodities, right, like, okay, the value sort of is irrelevant. I think it's just important to really get to the underlying fundamentals. Just because something's worth a price doesn't mean you're competing on cost.
Thank you for that highlight. I think that's really important.
I think we've got one last question coming in on carbon capture for Bill. Is the plan still to develop a demo prototype in early 2021? And I think this leads into, I guess there was one more question that we kind of missed, if we can do really quickly. What are the other various companies that are in direct air capture? How far along are they? And where are they on the cost curve? I know, Matt, you or somebody alluded to this earlier, maybe Bill with the $200 to $600 number. So Bill, status of prototype, and then broader direct air capture, where are we today?
Carbon engineering and Climeworks and Global Thermostat and a few others are all pretty far along. I think have working demonstrations and are working to scale and are all somewhere in the 150 to 450 range. But I'm not sure about exactly sure about their price.
Yeah, I've seen a little bit higher. I know Climeworks just announced a 4,000 ton per year facility, which is very small compared to the amount of CO2 coming out of a power plant, which would be millions versus 4,000.
Right.
And I believe Carbon Engineering, I'm sorry, I did a little homework tonight or last night, was in doing feed studies with Oxy. So these are Carbon Engineering's technology requires massive calciners to work. And so everything they're looking at is in the millions of tons per year, or at least hundreds of thousands of tons per year space, which then requires a $5 to $15 million front-end engineering study, which a couple of those just were announced by the DOE that they're helping to fund some of that. But those are major projects. I don't think that there's been anything built on the scale that's above a couple thousand tons per year. Is that consistent with Bill, you and Matt?
There's no reason to do this small. I mean, not just for the climate imperative, but to tap your public policy. You know, if you're going to drill a sequestration well or you're going to get 45Q, you've got to be in the hundreds of thousands of tons per year. So there's no tiny about this, unless you're going to, like Bill said, you might have your niche thing with Coca-Cola, but that's not gigatons or gigadollars. So you really have to be clear that it's a stepping stone to something else.
Yep. And for us, we are shooting to build a 1 ton per day demonstration still by the end of this year, and then use that to raise money to do the hundreds of tons per year that Matt was talking about next year. We would like to do that at the end of next year after proving it at a smaller scale. But one important thing about our system is it's modular, so we don't have to build a single large unit to prove it. We just have to repeat a smaller unit and just get the economics of building many of them. We hope that will be the proving point for us. We'll see how that works out.
Thank you, Bill, and thank you, Volker, and thank you, Matt. You know, it was so inspiring to hear you talk about this. And you know, big problems are also big opportunities that we're really excited about working on solutions with entrepreneurs on. We're very grateful for kind of the three of you engaging on such an important topic, and most importantly, really making it accessible for all. I hope everyone on this call was able to take away some more interesting knowledge around carbon capture and why we think it's a compelling opportunity for society and from an investment perspective. So again, this was the first of our 8 webinars. Same time, same place. Next week, we'll be talking about batteries. And thank you guys so much. And stay safe out there.
Thank you, everyone.
Thank you all.
Bye.
Bye.